Okay, all right. Good morning, guys. So we still have a couple of sessions, a couple of topics to cover, and then very soon we'll be bringing our training to a close. So I think last week I closed the session. Actually Friday, but I closed the session with a process flow diagram. So this is what I need from you guys. I'll need you guys to work on the same process flow diagram that I did. I think the when I was about ending, and not only that, you guys will do that and turn that in, send that to me by email on by Wednesday, and also you guys will do the same thing for the Gmail. So I'm gonna need Gmail login process flow diagram as well, right? So you guys will be working on two assignments: the Gmail password reset. Listen to it carefully. Password reset process flow diagram, and then the CRM tool that we did process flow diagram. So the only way that I can come to a point where I know you guys fully understand and comprehend process flow diagrams and the practicality is for you guys to work on these two assignments for me. So you guys will turn in the CRM assignment and then also work on Gmail password reset. So simply go to Gmail and look at the password reset and look at all the processes involved, and then you put that process into a process flow diagram format, and then you send it out to me. You're gonna use Lucidchart. So last week I asked you guys all to create an account with Lucidchart, right? So go ahead, create an account with Lucidchart and work on that assignment and then turn it in for me. All right. Good morning once again. So today we're starting with database. So far we're working on SDLC, working on a couple of things that are interesting. But when we build application, when we give our customers, our end users great, awesome user experience, we build great portals, great software application, great tools, where does the data go? See, we need to start asking ourselves these questions. When these tools are built, when customers come on our portals, to shop, buy items, don't aren't we supposed to save some data somewhere? Aren't we supposed to have the records of these sales and records of the clientele that we have? Aren't we supposed to have this data somewhere? So it's very, very important that we take a look at data and then databases, right? We take a look at that briefly, and then it's up to you guys to read more and research more about databases. I'll just share some key resources with you guys so you guys can learn more about databases. For the training and for the purpose of this, training, I'm just supposed to expose you guys to some key database concepts and some other things that will serve eventually as pointers. And then if you want to take a deep dive, it's up to you to take a deep dive. But I can also share some key resources that can help you take a deep dive. So let's keep going. Let's move. So one fundamental key question is going to be, what is data? DATA. What is data? We need to be able to understand what data is, how we use data um, in every organization. I think this is very fundamental. This is very common in every organization today. I think we collect data. We have data of to a certain degree, It could be your employees' data, right? If you start an organization, you're gonna have data of employees. You're working with people, so you're gonna keep some records somewhere. You're gonna keep records of salespeople. You're gonna keep records of different individuals, or different verticals across the organization. What is data then? Data, there's a characteristics or information, usually numeric, that are collected through observation. So in a more practical, a more technical sense, data are a set of values of qualitative or quantitative variables about one or more persons or objects, while a datum is a single value of a single variable. Kind of technical a little bit, right? All this language, yeah. But essentially, what we're saying is that data are a set of values of qualitative and quantitative. So two things here I want you guys to take note. Qualitative here means that, when data is collected and we know exactly the, categories and groupings of this data, essentially, we are able to have great data about what we're doing as an organization for our business. And not only that, we are also able to make data-driven decisions, right? Quality. So this is where the qualitative attributes comes in. Our ability to decipher, look at the data, and make critical decisions, right? Make critical decisions based on the data. So we can look at our sales from different parts of the country and say, okay, in the Midwest, in the East Coast, from the New York, Connecticut, Boston, all those areas, we're doing very well. This is our sales, this is our graph. Let's concentrate more. Let's increase our budget on advertising, based on the sales revenue data that we're looking at. You can look at the Midwest, say, well, Wisconsin, Ohio, Chicago. Let's look at this region. Okay, let's look at the West Coast, California. Let's look at all this other sales. So we want to be able to make qualitative, data-driven decisions, right? Based on how we're able to read the data that we have. And then quantitative, that means the number of data that we have. It's about quantity here. The aggregate, of our data. We have a lot of data. And guys, let me also make this point. Data, like we always say, arguably, it is the most critical asset of any organization right now, right? If you're an organization and you don't have data, then that means I don't know where you're going. You don't really have a future. You need to have data of all forms, data of all formats, and you got to be able to start making decisions based off on data. We don't want to make decisions based off on emotions, right? In business, we don't do that. It's not I feel like, I think like, we don't make critical decisions, spend billions of dollars on different budgets based on just your intuition and emotions. No, you will have to let the data speak for itself. We got to make DDD, the decision has to be based on data, data driven decisions. That's what we call it, DDD, data driven decisions. So we need to know, why are we doing this? Why do we want to go to this region? Why do we want to go to this country? What is the data there? What's the size of the population? And among the population, what's the size of the youth from 17 years to 35 years to whatever. We got to make decisions that are based on data. In Africa, one of the most promising continents, very youthful age, class. if anybody wants to go into Africa to do business, they really have to look at the data. They have to critically examine the data and know, okay, let's go to the west, let's go to the south, let's go to East Africa, let's go to North Africa. There has to be something that will essentially drive people to make one or two decisions. All right, let's go ahead. So once we have qualitative and quantitative data, then what next? We need to have what we call database, right? So what is a database? A database is an organized collection of structured data to make it easily accessible. A database is an organized collection of structured data to make it easily accessible, manageable, and update. So in simple words, you can say database in a place where the data is stored, right? So an organized collection of structured data to make it easily accessible, manageable, and also update. So once we're collecting the data for our customers, it is very, very, very important, right? The reason why we do this is that we want to be able to have, or make, the data of our customers accessible somewhere, right? And we also got to be able to make it manageable, right? And also we got to be able to update. For instance, when we start, collecting data of our employees, right? We can access anytime and say, yes, when somebody come and ask us question for auditing purposes and for whatever purposes, we can access it anytime, anywhere. And that is just one. Number two, manageable. So that means we can manage it. We can move people around to different departments and different units, send them across different regions across the world. It can start from just organization with maybe 20 people, 10 people, 50 people, to almost 10,000 people. There are companies and organizations that have 50,000 people, employees, more than that, right? And you need to have a database to be able to manage even your employees alone, let alone your clientele, your customers, right? So it makes it easily accessible. We can go to a database, our repository, and say this is where the data is stored. And that's one, access, can have access to it. Number two, manageable. We got to be able to manage. We got to be able to manage the data of these folks or individuals. And number three, update. We will keep hiring people, right? And once we keep hiring people, what do? We need to update these tables. We need to update our database with this new set of people that we've hired. So it's very, very important, right? So database in a nutshell is a place where the data is stored, right? Database is a place where the data is stored. So that's what we call database, right? Database is just a place where the data is stored. Very important. So let's look at the types of the database. Types of databases. Okay, all right. So we have relational database. We have object-oriented database as well. We have distributed database. We have NoSQL database. We have graph database. We have cloud database. Cloud database is getting very popular. We have centralization database and we have operational database, right? As you can see, I've got three of these databases highlighted in blue, right? Relational database is very popular. Relational databases is what we see all around us for most organizations that harness and take advantage of database structures and build silos of data warehouses. Most of them and most people all go with relational databases. So relational databases, exactly what we mean is that when you get into a table, you're going to have rows, you're going to have columns, right? You're going to have different tables and different attributes. These are what we call relational database, right? Relational database is simply our ability to store data, but it is well structured, right? We have all these columns, we have rows and etc., right? That is what we call relational databases. Cloud database is becoming very popular. The most common cloud, platforms when it comes to databases or when it comes to cloud solutions. The popular ones are Amazon Web Service, so AWS. Amazon Web Service is one very popular. People are using it. They're making millions of money as well, right? A very efficient infrastructure when it comes to cloud solutions and cloud databases. So AWS is one, and then we have Microsoft Azure. Microsoft Azure. So you see, you guys have seen it somewhere already. Somewhere, Microsoft Azure. So Azure is A-Z-U-R-E, 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 A-Z-U-R-E. So called Microsoft Azure, and then we have GCS, Google Cloud Services. So GCS is also very popular. So the three big ones that are very popular when it comes to cloud databases and cloud storage and cloud based hosting services. We have the AWS, the Amazon Web Services, AWS, and then we have Microsoft Azure, and then we have GCS, Google Cloud Services. I think AWS, maybe has the biggest market share, followed by Microsoft Azure, and maybe followed by GCS, Google Cloud Services, in that order. And then we have NoSQL, NoSQL database structures. I want you guys to take note. So these are the popular ones, the types of databases that we have: relational databases, object-oriented database, distributed database, NoSQL database, graph database, cloud database, centralization database, operation database. Moving on. You guys may have heard of SQL. SQL is just the acronym for Structured Query Language. Now that we have our employees, data, now that we have clients, our customers' data, we have clients of about 2 million clients. How do we check the records of client B or client A or employee B or employee Z? There is a certain language that the database can and will understand, right? You cannot go to the database and say, database, give me this. You got to be able to speak to the database in a plain language or in a format that the database will understand and give you what you want, right? So we have huge database. Let's say we have, terabyte size of database, right, for our customers and for data transactions. And if we want to retrieve a record, we got to be able to write a structured query language. The language that the database understands is what we call the structured query language, SQL. So SQL is a language that we write to be able to retrieve data from the database, from the record that we have kept, right? From the record that we have for our clients and customers. So we write the SQL language. So structured query language, SQL, is pronounced as SQL, right? As you guys can see, it is one of the popular, terminologies that you will hear in our type of setting or type of environment. SQL, people don't necessarily call it SQL, but they use this term SQL, SQL. So you will hear it, SQL. Just write a SQL query. You just write a SQL. So SQL is what they're talking about. That's a structured query language, which is the standard language for dealing with relational databases. Because relational databases, they have columns, we have rows. If we want to retrieve something, we write a basic query and say, select from this table employees and give me all employees that their name starts with S, their name starts with a B, their name starts with a K, The name starts with a G or J or an O, and the database will give you all the records in the database with the data or with their names starting with that, the data that you've just prescribed, right? So you need to write a SQL, a structured query language, to be able to get the data out from the database. Let's look at the advantages of having a database, right? Advantages of having a database. Number one, it reduces data redundancy, right? Very, very important here. It reduce data redundancy. See, when you are writing data of your employees and you have 10,000, you have 15,000, you have 20,000, 25,000, right? I mean, this is huge, right? This is huge. The tendency that if you were doing this in a manual process, in a manual way, the tendency that you're going to forget or you're going to repeat something is very high. So when you're using a database, it's able to check your unguardedness. It's able to check and then ensure that you don't repeat some of this data and have the same data attributes for the same individuals in the database. We don't want the integrity of the data to be corrupt, right? So it's very important that we build databases that can check for data redundancy so that we don't have multiple repetition and replication of the same data inside our databases. We don't want that to happen. Also, there is a reduced updating errors and increased consistency, right? When we have, structured data, it reduces the kind of errors that I just talked about, and also it increased consistency. All our data, as we keep saving, as we keep building, we keep piling up, will follow a certain pattern. And that's why we say it will increase consistency, right? Easier data integrity from application programs. I just mentioned that. Improve data access to users through the use of host and query language. Data security is also improved. Even today that we have, different databases and all these, security services and, security stuff are available to us. Every now and then you still hear about some breach, some breach of, some data. There are popular ones that when you Google right now, you will see and you will hear about some of this data breach. Some of the hotels, big chain hotels, they have customers' data, their credit cards information, all these things, breach, but essentially when data is stored properly and you have databases, all these things are a little bit, curtailed. So data security is also improved. We get better. At least it's better than having it all out there without any form of security, right? And then reduce data entry, storage, and retrieval costs. This is also very, very important. And of course, we cannot just talk about advantages without also talking about the disadvantages. So complexity. So you have complexity here. Databases are complex hardware and software system. As you guys will imagine, the databases, it can be a little bit complex. It can be a little bit complex. You'll have to spend money. You have to spend some little money on, getting some, hardwares and different systems, right? So it can be a little bit expensive, right? It can be a little bit expensive, very complex as well. And of course, it comes with its own costs associated with it by hiring and getting people to be, your database administrators and whatnot. So there are so many things that goes into it, right? Cost. It requires significant upfront and ongoing financial resources. I just mentioned that. Um, you're going to spend some money in buying this, spaces and storage, cloud storages, and you're going to pay all these licenses and annual renewal fees. And of course, you also need to have people to be able to man the database, right? You're going to have staff, employees, who you got to pay them so that, they can be the administrators for your databases, right? So you got to hire people as well. Security. Most leading companies need to know that their database systems can securely store data, including sensitive employees and customer information. This is also a key point here. And then compatibility here. There's a risk that the DBMS, the database management system, as a DBMS, might not be compatible with companies' operational requirement. Sometimes when you need the system to be able to conform to a certain pattern, a certain way on how you guys work, sometimes you might have compatibility issues that must be you need to have a workaround for that, right? You need to have some issues resolved here and there so that as you guys operate, your operational needs can be addressed by these database systems, right? So there you go with the advantages and disadvantages of having a database management system. Moving forward. Now let's look at, the different types of the SQL and how we manage databases over here. We've got a couple. We have DDL. So DDL, what does it mean when we say DDL? So DDL is data definition language. Now we're looking at the management of the DBMS, the database management system. How do we manage it, and how do we ensure the integrity and manage it as an asset of the organization. So DDL is data definition language. Data definition language are used to define the database structure or schema, right? So we have different languages that we use when it comes to DDL. We have different languages. So we have create, for instance, right? We have a language called create. And when do we use create? We use create to create objects in the database. We can use create to create tables, new tables as required or as needed. So that's when we use create. And maybe tomorrow we might take an example of all these type of things, or I'll show you guys. I will just share maybe a resource to you guys. I think I can go over there and then create tables for yourself and play around. We have alter, right? When and how do we use the alter? So it alters the structures of the database, right? So sometimes, a database may have been created, a table may have been created a long time back ago, and you guys need to update and change something in the structures and say, let us now allow this table or this this table to have maybe one more column, and inside that column that we are talking about, maybe have additional data values in there, right? Maybe increase the number of characters that data field would normally have. Maybe we want to increase, we want to add more, because we're finding out that some of our new customers that are coming in, they come with different set of features, and so we need to accommodate and update what we have in the database so that we can take those information also in. So alter. So we alter the structures of the database. We have drop. And when and how do we use drop? So drop is a language when we want to delete objects from the database, right? So drop when we want to delete objects from the database. That's what we use drop. And then we have truncate. Truncate. When do we use truncate? Truncate is used to remove all records from a table, including all spaces allocated for the records, right? Truncate is remove all records from a table, including all spaces allocated for the records, right? For the records. So it's also very, very important there. And then we have comment. As we are building all these huge, if you like, humongous, databases, we got to be able to comment so that people that come after us, whether we are there or not there, they will see the kind of comments and other things that we've made in the database, so they can also follow the same standard that we have in there. So if we have some comments, they have commented on something, they can read it and they will be able to get informed about how to handle something in there. So comment, we use that to add a comment to the data dictionary, right? We use that to add a comment to the data dictionary. And then rename. So rename, just like you guys already know, when we use rename, it's just to rename an object, to give another name to an object in the database, right? That is rename. So giving a new name and we add a new name to it, changing the already existing name and giving it a different set of attributes, right? Data attributes, rename. So we looked at DDL. Let's look at DML. DML. Probably this will be the most common ones that are used. DML. The DML, what does it stand for? It is data manipulation language. Data manipulation language. Just like the word manipulation. Somebody wants to manipulate somebody, manipulate something. It means have some effect and change certain things, cause the database to behave in a certain way. So what do we do with DML? DML are used for managing data within the schema, right? So data manipulation language are used for managing data within schema, right? There are common DML or data manipulation language, the common ones. So we have select. Select is like the most popular DML language, data manipulation language. We all use select. To be able to retrieve data from the database, you will have to write a select query, right? And say select star, select this column from this table where blah, 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 where the table data looks like this, and it will just pull this data for you, right? So that's how we use select. Select is just to retrieve data from the database. So anytime we're using a select, that's what we're getting ourselves into. Insert. So insert is also another DML language that is used for managing data. And when and how we use it for inserting data into a table. So let's say we have created a table called employees, right? We created a table called employees. What are we going to do next? We need to be able to insert values, data into this table called employees. We can have different columns like employee ID, employee high date, employee address, employee first name, employee last name, employee, date of birth. We can have different set of columns, different data inside that table of employees, right? And the only way that we can update and insert data into this table is by using the command insert, right? So insert is a data manipulation language, DML, insert. Now we have update. So that means update is different from insert. And I hope you guys get it. Insert means it's a new column, a new set of data that we are maybe inserting under a certain column that already exists, right? Update is updating existing data within a table. So there was already something in there. Let's say an employee address got changed, right? So that means there's already 2211 North something Drive or North something Southwest, maybe Atlanta, Georgia. Zip code is maybe 322. And let's say I moved from my current place to a different place. Something got changed. Maybe a department of the employee that, the data of that department, maybe first he was working for marketing department, right? Now he's moving from marketing department to maybe compliance. So we need to update the database so that it will be current. And when we need people, we need individuals, we know exactly where they are. If they got moved from sales to marketing, they move from marketing to compliance, or maybe core banking operation, or a different department, we should know, right? We really got to know what has changed. So we update this, data within the table. We have delete. Now, delete is very, very critical. We don't usually use delete, because we want to be able to have records. And you know that relational databases, data are connected to different set of data as well. We have something we call primary key and a foreign key. So there are tables that are interconnected, that interfaces with different tables and different data set as well. So delete all records from a table, the space for the records will remain. So that's what we do here to be able to delete. Merge upsert. Merge upsert. So this is also a DML, data manipulation language. It is used for operations to insert or update. Call. So we can call a PL SQL or a Java subprogram. Very, very important. So we can call a PL SQL or a Java subprogram and explain plan. So to be able to explain access path to the database. So explain access path to data. And then we have another DML, data manipulation language, called lock table. It is also used for controlling concurrency. Yeah, it's also used for controlling concurrency. And then we have DCL. DCL is data control language. Data control language statement. So DCL, we want to be able to control who can access, who can see what, for For instance, I think I mentioned this at um, earlier. I mentioned this sometime back about employees, database table and salary table, and who can access it, who can update. Imagine that as a company, every employee have 10,000 people, and everybody can get into the employees table and go into salary table and update and do all sort of things to this table. That would be chaos, right? It's going to be chaotic. So we got to be able to define and give users access to privileged database records. So who can access what at any point in time, right? Very, very important. Because not everybody is going to access every database table in our database. So we got to be able to define who is going to access what at any point in time. Who can have the privilege to access marketing data, sales data, revenue data, salary data, all those things. So critical. It is critical that we have this DCL data control languages in place. And then revoke. So at the same time that we're granting access to people or certain individuals, we also got to be able to withdraw access privileges given with the grant command. So as we grant people access, there are times that people move, people leave the company, they go work for different company here and there. We don't want them to be still having access and privilege to our databases and getting into our sensitive data, right? So when people are leaving, people move, we got to be able to withdraw or revoke the access that they had, right? If they were previously, they can access employee, salary table, and other sensitive, data of our customers. We don't want to do that. We don't want them to be able to access this whilst they are gone. So this is why this is very, very important that we sort of control and even monitor, right? Even be able to monitor, perform some monitoring duty, see who is accessing what, and there are logs all the time. There are logs all the time to track and trace who log in at this point in time. All right. And then we have TCL. So we look at DCL, data control language statement, which is grant and revoke. And then we have TCL, transaction control, right? So we have a couple of things as well when it comes to transaction control. Now, in a high traffic environment, companies that have transactions, moving back and forth every day, all the time, they might be using TCL. A lot of their, database administrators, not just database administrators, but, SQL developers and data analysts folks, they use a lot of TCL. So transaction, query languages. So we have commit. So anytime you use the command commit, it means you want to save the work done. This is what is used in saving the work that is done. So commit, right? Commit, very, very important. You use that in saving the work changes, all these things that have been done. So sometimes when we are updating this, we're writing a new query, we changing the database characters, we're adding new statements and new fields to database and all these things. After we've done all these things, if these things are high level, we need to be able to commit. We need to be able to save these changes so that they can take effect in the database, right? So That is what you use in updating something like a production, the data of a production environment. Especially that's where we use commit language, to be able to change something permanently, right? Save point. So we have save point. Save point is also another critical command. We use save point to identify a point in transaction to which you can roll back, right? So yes, let's say yesterday we were working on something and we've added more stuff to it, and then we run into issues, right? We run into a couple of issues. What we can do to to be able to make all of us happy is to be able to identify a point in transaction in which you can roll back. So let's say, Friday we started working on something in our database and everything is good, but we started having issues. We're now having a lot of issues. And we know that Sunday or Friday before 6 p.m., I think everything was working good. We didn't have any issues. And then all of a sudden or suddenly, we're beginning to see some signs of problems that we are likely to encounter. So what do? We identify a point in a transaction to which you can roll back. So we can say, let's roll back to Friday 4:30 p.m. when we prior to us touching something or started working on something. So that means the 4:30 p.m. is up to the time that everything was working good and we didn't have any issue. So that is going to be the save point. So the point or the time where transactions in which you can roll back. And then we have rollback itself, right? Another command here. Rollback is also very, very important. So now that we have identified a save point, what do? We roll back. We use a language to roll back. So rollback means to restore database to original since the last commit, right? So we can always roll back. So when we add something to production environment, to our live environment, in our databases, and then we begin to have issues, serious critical issues. Once we begin to have those issues, we can simply look at our database and say, let's roll back to Sunday afternoon. At this point in time, this was when all was well. It was great. Everything was working good before we did all these changes, and now we're having all these issues. So now let's roll back. It's very, very important. Now we can roll back. So roll back to an original since the last commit, since or prior to us having issues or having something work. So that is going to be the rollback time, right? That's going to be the rollback time. That's going to be the rollback time. So restore database to its original since the last commit. So the last time that we committed something, we want to be able to roll back to the original since the last commit. And then the next one is set transaction. So set transaction, what does that mean? So when do we use this command for set transaction? To change transaction options like isolation level and what rollback segment to use. That's what we use set transaction for. I think, yeah. So that's going to be it for the basic, database structures. I see there's a question over here. Let me grab that question real quick. So Eben is asking a question: is it possible to use multiple databases in one company? And if so, how would they relate to each other? Yes, to answer your question, yes, you can have multiple databases. Some companies have hundreds, right? Some companies have hundreds of databases, as you will imagine, and the reason why they have hundreds of databases, if you look at it critically, if you take a look at, Gmail, or let's say Amazon, or maybe eBay, or maybe Alibaba, there are transactions every second. Every second, there are like maybe thousands of transactions happening around the world on their platform. And so there's a need for us to separate or segregate all this type of data, data on purchases online, data on employees, data on this. There's so many data that we will have to keep. The data on receipts, data on previous orders. There are so many things that, these companies are storing, right? So there's a need for us to have multiple data, several, right? Several. We're going to have several of these, databases. Yes, to answer your question. Are there any more questions that I need to answer? We have some 4 minutes. Again, let me reiterate the assignment. So the process flow diagram that we did last week, I think I worked on something last week, Friday. I'll need you guys to work on it. You will label it nicely about the CRM tool for the recipe. You do that, and then you send that to me. And also, of course, the Gmail password reset, right? So you guys will work on the process flow diagram for Gmail password reset. Gmail password reset. So you guys will do that as well and send it over to me. Gmail password reset. So I need that as well. So I need these 2 assignments turned in by turning by Wednesday. Yeah, I need these process flow diagrams by Wednesday, and you guys will have a project also as well. Wednesday, I'm looking forward to giving you guys. This is going to be your last project that you guys will be working on. Say, can you please upload the class session for the process flow? It's already uploaded. You guys can check out the YouTube channel. It's already there for last week Friday, so you guys can go back and then look at the video. And if you want to pick up some inspiration and some few things from out of that video, yes, it's already up. So you can always go back and check over there. Or if you want me, if what you are talking about is maybe the link, you want me to share the link to that video, yes, I can. I'll share the link. Yeah, if that's what you're asking for, yes, I will share. I'll share the link, and I think the video that piece should be at the very tail end or the very end, towards the end of that session for last week Friday. You'll see it over there. All right, guys, I will. If there are no more questions, we have some 2 minutes or something. Yeah, it's 5:58, almost 6 a.m. If you guys don't have any question, I will see you guys tomorrow. Tomorrow we will touch on decision tables. Yeah, decision tables. So tomorrow session 2 is also very, very important that you guys come early so we can start something, and then some other things also done. So decision tables is what I'm going to be working on tomorrow. Yeah, somebody speaking.
Yeah, good morning, everyone.
Good morning.
You mentioned that we will touch on change management.
No, we already did change management. That was about maybe the last 4 sessions that we did. We did change management.
Oh, okay.
Yeah, you can go back to the videos. I think it's in there. Yeah, change management. We already did, change management. So gradually, we're coming to, the end of all these trainings, and there are about maybe maybe 3, not more than 4 topics left. That I need to cover for you guys. So we are almost there, guys. We are almost there, and some of you will start working on your projects very soon, and others are even starting already. So we are almost there. We are almost there, guys. Some of you will start working on a project. Hopefully by the end of this month, most of you will start the project. I know Kofi is starting today. Kofi is starting his project today. So hopefully, all of you, will start working on the live project with different organizations and companies in real time. All right, guys, I'll talk to you guys tomorrow. Okay. All right.